Hello everyone, and welcome back to the good stuff that we have been doing. Today in this video we are going to compute the so-called standard integral for logarithmic functions, and this is the general form of the log sine or log cosine integral, because we know the simple form of these integrals are well known, which is the integral from 0 to, let's say, pi over 2 of the logarithm of sine of x. Also, this is equals to the integral from 0 to pi over 2 of the logarithm of cosine of x, and this integral are well known and they are equal to negative pi over 2 log 2. Now this is more like the general form where we have the logarithm of a plus b cosine of x, or the logarithm of a plus b sine of x. So this is more like the general form of these integrals. Now this result usually becomes useful when you are computing inverse tangent integrals, as we shall soon see. In fact, the reason I'm actually deriving this result is because I'm trying to do a particular integral, the integral from 0 to pi of the tan inverse of 1 plus cosine of x dx, and this is equals to, what is it equal to? Okay, it's equal to pi times cotangent inverse of square root of phi, where phi is the golden ratio, equals to 1 plus square root of 5 divided by 2. And to compute this integral, it led me to computing an integral related to this, and for that, that's okay. I have not done a video of this beautiful integral on this channel, so let me just do it, and for the sake of completeness. So that means the next video I'm going to upload on this channel will feature this integral. I've already solved this integral though using a different method, but like it was super long, like a 35 minutes video, and I feel like, okay, this is too technical, let me make something simpler. And as I decided to use the fact that the logarithm of a plus ib is equals to the logarithm of the square root of a squared plus b squared plus I times the tan inverse of b over a. So tan inverse of b over a is the imaginary part of this logarithm, is the tan inverse. So basically I use the fact that this integral, in fact the details will be in the other video, but I use this idea and I came across this integral. Now we're going to compute it, and the technique we're going to use to compute this integral will be the so-called Feynman's favorite technique, and it's called differentiation under the integral. Okay, now how does it work? Well, practice makes perfect, because there are so many textbooks on Feynman's trick, and but the only thing I can tell you for free is that the only way you're going to master Feynman's trick is by just solving problems, trying yourself luck with it. So I'm not going to give a system or say this word, just do more problems, do example, as you shall soon see. Let's call our integral, let's call it f of a, and let's f of a equal the integral from 0 to pi of what? Of the logarithm of a plus b times what? Cosine of x dx. Now what we do next is that we're going to take derivative of this function. So you would have f prime of a, it will be the integral from 0 to pi of what? The logarithm of, no, you won't have the logarithm. You would have 1 divided by a plus b cosine of x dx, of course. Now this is a new integral we're going to integrate, and to do this we need to use the so-called Weierstrass substitution, which is like taking t to be the tan of x over 2, because in this case now dt would be 1 over 2 secant squared x over 2, and that would be 1 over 2 times 1 plus tan squared x over 2, okay, dx, of course, dx. So basically 2 dt divided by 1 plus t squared would be dx. So we have dx in the back. What about the limit of integration? Well, when x is 0, you basically have 0. So the new integral will run from 0, and when x is pi, you have pi over 2. So the new integral will run from 0 to infinity. Then you have a 1 plus a plus b. Now what is cosine of x in terms of tan x over 2? Well, it's not too hard to derive the relation, because you notice here that you have cosine of x will be 2 cosine squared x over 2 minus 1. And this is basically 2 over secant square x over 2 minus 1, and this is 2, let me write it this side, and this is essentially 2 over 1 plus tan squared x over 2 minus 1, and that would just be 2 over 1 plus t squared minus 1, and that would be 1 minus t squared over 1 plus t squared. So we can plug in whatever data we have arrived at and say and claim this is 1 minus t squared divided by 1 plus t squared, and on this side you will have 2 dt over 1 plus t squared. Now we need to just basically simplify, and this will land us to, let's say 1 plus t squared, they cancel out at the top, so you have a 0 to infinity of 1 over a multiplies 1 plus t squared, and then plus b multiplies 1 minus t squared, and then you have 2 dt. So we can bring out the 2, so you have 2 divided times the integral from 0 to infinity of 1 over, so you have an a plus b here, then plus a minus b t squared dt. Now let's factor the a minus b, so you have a 2 divided by a minus b times integral from 0 to infinity, and then you have a 1 over you have, let's say this is square root of a plus b divided by a minus b all squared plus t squared dt. And point for this, the reason for this is because recall at the beginning of the problem we indicated that a be bigger than b, so putting a minus b in the square root is valid here. But if a was even less than b, that means we are going to have a minus b minus a t squared, and in this setup here, that means we are going to be looking at the antiderivative of dt divided by a squared minus t squared, and this is not also too difficult to evaluate as well. But for the sake of simplicity, let's stick with the tan inverse on where a is bigger than b. Now in this case you have 2 over a minus b times what? Square root of a minus b all over square root of a plus b times the tan inverse of what? T times square root of a minus b all divided by a plus b, and we evaluate this from 0 up until infinity. Now when all is said and done, you will have 2 over a minus b times, now over here you have square root of a minus b all divided by a plus b, then you have a pi over 2. Notice how the 2's they neatly cancel out, and also square root of a over a is just 1 over square root a, so you will have something like pi times square root of 1 over a minus b and a plus b, which is pi divided by square root of a squared minus b squared. So essentially now we have that f prime of a is just pi square root of a squared minus b squared, which means that f of a which implies that f of a would be the antiderivative of pi over square root of a squared minus b squared plus c rather. So in this case you will have the antiderivative of this is basically the logarithm of a plus square root of a squared minus b squared, then you have plus c. Then this plus c is basically the constant here. You can find c by just taking whatever for a, like if you go back to your original problem now, and let's say you set b to be 0. For simplicity, we're going to set b to be 0. That means your c would be the integral from 0 to pi of log a, which is going to be pi log a. Okay. Yeah. Take a to be 0. So you have c will be just pi log a. Sure of that. Okay, so when hold on, let the whiteboard still loading. Okay, so hold on. Yeah. Okay, this is not the value of c yet though, because if you plug in b equals to 0, f of a becomes pi log a. So now let's see if we can match the constants. Yeah, so let's set pi log a to equal to logarithm of a plus square root of a squared minus b squared at plus c at b equals 0. That means you would have pi log a to equal to logarithm of 2a plus c, which means c would be, so pi here rather, so which means that c would be pi times log a minus, hold on, so c would equal to pi times the log a minus the logarithm of 2a, all in brackets. So that would be pi times the logarithm of 1 over 2. Okay, so essentially f of a would be pi times the logarithm of a plus square root of a squared minus b squared plus what, pi times the logarithm of half, which is just going to be pi times the logarithm of a plus square root of a squared minus b squared, all divided by 2. So essentially we have evaluated this integral from 0 to pi of the logarithm of a plus b cosine of x to dx to equal pi times the logarithm of a squared. Is it an a squared term? Okay, just an a, so it's just an a times plus square root of a squared minus b squared, all divided by 2, and that is all. So thank you very much for watching, and please do subscribe to the channel. Bye.